This video is about Amazon Rekognition service. It is a fully managed computer vision service that helps automate your image and video analysis. It is based on deep learning technology, thus helps avoid manual inspection, as extracting specific insights in images and videos is costly, time-intensive, prone to error, and hard to scale. You get highly accurate facial analysis, for example, face-based user verification. Amazon Rekognition enables your applications to confirm user identities by comparing their live image with a reference image. Amazon Rekognition is a simple and easy service to quickly analyze pictures and videos stored on S3. You can easily add image and video analysis capabilities to your applications through simple API endpoints. Now let's look into its use cases. You can also perform analysis by matching objects, scenes, segments, and text detection in large numbers of images and videos. You can automatically tag or label media content to make it searchable. You can also flag any inappropriate content to enforce policies, comply with regulations, and protect your brand. You can identify and verify users such as customers and students by matching their faces with their identity document pictures. For example, picture ID using facial analysis. The most interesting part is how we use Rekognition to extract relevant information from images so that we can store it in DynamoDB. To get this, we set up a simple pipeline that takes pictures uploaded into an S3 bucket and fires an event that causes an AWS Lambda function to execute. This Lambda function calls Rekognition APIs, for example, Detect Labels API to detect objects and scenes detection, and Detect Faces API to perform face analysis. You could also use other APIs like the Detect Text API to find text inside images, or Detect Moderation Labels API to perform unsafe content moderation to extend the application capabilities further. The Lambda function processes the results from API calls, stores the results into DynamoDB, and the results are ready to be queried by our web front end. Build a static HTML page for searching and filtering the images hosted on S3. The search queries call a Lambda function via API gateway to look up images tagged with results we obtained via Amazon Rekognition. That is stored inside the DynamoDB. This is a serverless and event-driven image analysis pipeline. With this setup, it's easy to scale. Furthermore, it is extremely cost-effective because we are not paying for any idle server time because of the serverless nature of the application. We have seen how Amazon Rekognition analyzes images. What about video analysis? There are countless opportunities to innovate and find actionable insights from the video content, from personal entertainment to physical security, to in-store customer behavioral analysis. The old classic video analysis technique was to sample still frames from a video feed, performing analysis on these images one at a time. In some cases, this approach can work, but there is a lot of opportunity for improvement here, and Amazon Rekognition does an excellent job of performing video analysis. Amazon Rekognition can perform analysis on videos stored on S3, and can perform analysis of streaming video content as well. Video is all about motion over time. This builds up context. For example, the adjacent frames are related, and a good analysis should consider this. It's hard to leverage this temporal context if we just perform a simple frame-by-frame analysis, looking at an image in isolation. It doesn't surprise you that Amazon Rekognition does this type of analysis, but it does it in a way that preserves this context. As a result, you can perform object and activity detection, person tracking, facial analysis, unsafe video detection, celebrity recognition, and face recognition for video files. Rekognition also allows you to perform searches of detected faces against a collection of faces you've previously defined. For example, suppose you have defined a collection of faces with the Create Collection API and populated it with results from the Index Faces API. In that case, Rekognition can search your videos for matches against the collection using the Face Search APIs. It lets you detect explicit or suggestive content in your videos. It enables you to flag or filter content based on the needs. Amazon Rekognition also can perform person tracking. The person tracking feature lets you follow a person throughout a video, learning their position in each frame and timestamp when they are seen in the video. It can also track people through frames when their faces are obscured or not facing the camera. The Get Person Tracking API returns this location information for each detected person and any detected facial landmarks for each person. Let's see how Amazon Rekognition works. Unlike Rekognition API's operations for images, which return results immediately. Analyzing videos works asynchronously. We start by storing files on Amazon S3. Then we call one of Rekognition's asynchronous APIs, like Start Face Detection or Start Celebrity Recognition, by inputting the information for the location of video files on S3 and a resource identifier or ARN for the Amazon SNS topic. After the analysis finish, Rekognition publishes a notification on the topic we provided. We connect to this topic to invoke a Lambda function, which then fetches the results from Rekognition using the next appropriate call like Get Face Detection or Get Celebrity Recognition. When the Lambda function gets the results, it stores them in DynamoDB ready to be queried from a web app. The web app makes API gateway calls to call the Lambda function to fetch the result from the DynamoDB. Amazon Rekognition can do video streaming analysis using Amazon Kinesis Video Streaming. Amazon Kinesis Video Stream is a secure and scalable service for streaming video from connected devices to AWS for analytics, machine learning, and other processing. It automatically scales the infrastructure needed to ingest streaming video data from millions of devices. It also stores, encrypts, and indexes your video data in your streams and allows you to access it through easy-to-use APIs. To send streaming video data into a Kinesis video stream, you need producer SDKs. The producer SDKs. Currently, there are producer SDKs available for Java and C++ that makes it easy to stream video data to AWS securely. Then, once your streaming data is into the Kinesis video stream, you can point to Rekognition for analysis. Using Amazon Rekognition, you can detect content that is inappropriate, unwanted, or offensive in images and videos. This feature can be used in social media, broadcast media, advertising, and e-commerce to help create a safer user experience. You can set a minimum confidence threshold for items that should be flagged. The flagged content can be manually reviewed in Amazon Augmented AI. The content moderation feature also helps comply with regulations. Content moderation feature can be used. Comply with regulations in social media, broadcast media, advertising, and e-commerce to help create a safer user experience. Let's look into key points now. It can use to find objects, people, and text in images and videos. You can perform facial search and facial analysis for user verification. You can perform face search and verification, celebrity recognition. You can create a database of familiar faces or compare against celebrities. Use cases, labeling, content moderation, text detection, face detection, and analysis. Image analysis, video analysis, streaming analysis, and content moderation. This was an overview of Amazon Rekognition. Hope you liked it. Let's meet in the next video.